So hey guys, my name is Rongan Sarkar. I am currently a first year undergraduate student at National Institute of Technology Durgapur, and I am currently pursuing computer science and engineering. So a brief academic qualification about me is my GMAIN percentile is 99.45. My WBJ rank was 209 and I cleared the ISI exam. So hey guys, this is a problem solving video. This is my first problem solving video on the channel. So I would name this playlist Brain Teasers Part 1, right? First video of the playlist Brain Teasers. So without any other talks, let's get started. Okay, so here is a hemisphere of mass m and radius r that's given, and there's a light rod with a mass small m attached to it, and this length of the light rod is given as 2r, and the radius of the hemisphere is given r. So it is given rod is released from the vertical position, ball hits the hemisphere orthogonally. Remember the word orthogonally, okay, because that's a keyword here. Every time you read a question you should go through the keywords. Collision is elastic, that's another thing. Now we have to find the velocity of the hemisphere after it hits. Okay, so first we have to, in collision problems, first we are required to draw the situations before and after the collision. Okay, so before the collision, let's draw the situation. Okay, so this would be like theta. We don't know theta right of now, as it is said it is striking orthogonally, so this angle is clearly 90-degree. Okay, anyways, if at any point it would have been a tangent, right? And also the velocity in this direction is u, that is the velocity of this mass m. Okay, now this length is 2r and this length is r, so we have to find out what is theta. So tan theta we can write perpendicular by base. Tan theta perpendicular by base. Okay, so tan theta would be perpendicular by base. Okay, so it's 1 by 2. So now we have to draw the situation just after the collision. So we have figured out that theta is 1 by 2 and we have an unknown u, right? So just after the collision, what would happen? What would happen? Let's see. This m mass would have a velocity of v2 in this direction, and this sphere would have a velocity of v1 in this direction, and this is theta. So how many unknowns we have? U, v1, v2, three unknowns. Okay, so the basic thing that we should do in all mechanics problems in JE is we have to write the energy conservation equations, the linear momentum conservation equations, and E is equal to 1, we have to utilize that the collision is elastic. Okay, first let's write the energy conservation equation. Okay, so this mass was at a distance of 2r from the ground. Now what's the distance from the ground? It is 2r sine theta, right? 2r sine theta. Okay, so potential energy change. Okay, let me write energy conservation, mg 2r minus 2r sine theta. Change in potential energy is equal to obviously kinetic energy, right? Half mu square. Now let us write the equation. Equation means E is equal to 1, velocity of separation by velocity of approach. So what is the velocity of separation? So see, this is the line of action, right? This is the line of action. This thing. Forget about this. This is the line of action. So what is the component of V along this line? The component of V along this line would be V into cos of this angle. So this is basically this angle alpha. So let us figure out what is alpha. So this angle is theta, and theta plus alpha is 90. So alpha is equal to 90 minus theta, right? So along this direction, the velocity of separation is v2 minus v1 sine theta, and velocity of approach is clearly u minus 0 because the sphere was initially at rest. See, just it was just the u. Okay, now the next thing that we have to write is the linear momentum conservation. So we see there is no external force acting, right, on the whole system. So if there is no external force, we can obviously conserve linear momentum. So now many of you guys must have the question that is in this collision, what about the force that is experienced during the collision? Means during the change u and v2, sorry. So we are considering the whole m mass along with the sphere a system. So internal force we don't consider, only external forces are impulsive. Internal forces are never impulsive. So we can easily conserve linear momentum along the x-axis because there's no external force along the x-axis or in the horizontal direction, to be precise. So we write m into u into this component, right? So this is theta, means this is theta, so this is 90 minus theta, so mu sine theta, plus the linear momentum of the sphere is 0. Final momentum of the sphere is m into v1 plus the momentum of the ball on top of the light rod. So we have to get this component of the velocity. So this is theta, this would be theta, and this is 90 minus theta. Okay, so basically this is theta, and this is 90 minus theta. Okay, so plus minus m v2 into sine theta. So we got three equation, three variables. Now let's solve this. So v1 minus v2 sine theta is equal to u sine theta. Just I am rearranging this equation. Another what we got, v2 plus v1 sine theta is equal to u. So if you multiply this by sine theta and add them, okay, so v2 sine theta gets cancelled. What we have left, v1 plus v1 sine theta into sine theta, it is v1 sine theta whole square, and u sine theta plus u sine theta, that is 2u sine theta. So v1 is equal to 2u sine theta divided by 1 plus sine square theta, right? Now we already know u from this equation, so this would be u is equal to 2 into root under gr minus 1 minus sine theta. Okay, let me check once again. 2 root gr minus 1 minus sine. Okay, so just put it here. 2 into 2 4 root gr 1 minus sine theta into sine theta by 1 plus sine square theta. Okay, We know tan theta equals half, so sine theta would be 1 by root 5. So you substitute the values and you get the result. Okay, so this was all about the video. So if you're new to the channel, please don't forget to like, share and subscribe, and मिलते हैं guys next video में. चलो bye bye.